How do you build an AI-based e-commerce online store app with 10 microservices deployed into Kubernetes cluster with real-time messaging and scalable backend along with OpenAI integration? So in this video, we are going to implement step-by-step process. Front-end to backend, data to messaging. So we are replicating real-world scenario. Let us see that. Now first let us walk through our application functionality. So online store we are going to set up. So here first let us see, these are all customers as well as admin. Let me show you picture as well. So this is the online store we are going to set up. So here we divide into three layers: front end, back end, as well as data and messaging. So here customers, they'll try to visit the store. So by using front end called storefront, from there they'll try to place orders. Also they will try to place orders products and they will try to select the product, right? So once it is done, so whoever admins are there, store admins, they will process the order. So they're all related to backend. And also just see data and messaging. Whenever they are trying to place orders will be placed in this queue, so with our RabbitMQ. And also backend database we are using OrderDB, MongoDB. And also just see backend services like we are using place order, Node, and product service REST, and order processing Go language, and also one more service for AI. We're using OpenAI with Python. So also we are trying to integrate with OpenAI service also. So front end we are using Vue.js. These are all parameters related to our online store, front end, back end, data messaging. Now let us go back to our slide. So here customers, so whenever they're trying to place orders, so what type of access they're having? So view products, they can view only products. Also place orders and see on orders. But they can't change prices, see others orders, delete products. These are all related to customer permissions. And coming to the admin add edit products, view all orders, cancel any orders. You can see customers as well as employees, or nothing but store admins, you can see. Now, so let us see other structure also. So already we discussed front end layers, storefront as well as store admin. Front end users, they will try to place orders, and store admins, they will try to process orders. And after that, we can see backend services. So just now we discussed place order, order processing, product service. These are all services we discussed. And next one, data and messaging. So just go back to this picture. So we are using order queue as well as order DB. These two we are using stateful services. Okay. Stateful. Okay. So let us see here. To store orders, we are using MongoDB. Also, so order queuing, we are using RabbitMQ. And let us see this. Why we need stateful? So let us see why we need stateful. Let us see that. So we need persistent storage. Whatever orders we are placing, we need to store that orders proper way. And also stable host names. And also order startup. So you can see, if you need persistent storage, you can go for stateful set. Okay. Generally, we are going to use deployments, but instead of that, we are using persistent storage, stateful set. Also, we need fixed naming conventions. For that, just go for stateful set. And also sequential. Suppose whenever you're trying to scale, it is a sequential order. Right? So due to these reasons, we are using our persistent storage, and stateful sets we are using. Similar way, you can see our RabbitMQ also. Okay. We should not lose any orders, lost orders, right? For that, so we are using stateful. Okay. Also, we need fixed pod names, right, for clustering, and also sequential scaling. Due to this reason, we are using stateful sets. Okay. And next, so we need simulation services also. So as of now, we are trying to place orders with these services, virtual customers and virtual worker. We are creating two more microservices. So we are using these two scenarios only. We should not use these services in the production environment. It is only for demo purpose only. And then, so this is the entire architecture you can see. Okay, storefront, after that order service, then go to admin panel. They will try to retrieve from database and messaging queue. And again, just go back to storefront. So also we selected different languages here. Here we already discussed. Okay. So JavaScript, Golang, Rust, and Python. Now we are going to set up this process, step-by-step process. So let us see this manifesto files also. These are all manifesto files we are using, different microservices. So whatever services we discussed here, we already drafted this microservices, YAMLs, manifesto YAMLs, you can see. Front end, back end, and OpenAI data and messaging, virtual customers, as well as worker. So now let's identify prerequisites. So we need one Kubernetes cluster, and also we need OpenAI. We are going to use Azure OpenAI service. So first, let us start with Kubernetes cluster setup. So let us see that. So here there is a console or Azure console. So within that, let us use our Kubernetes service. So here I'm trying to set up my Kubernetes cluster. So within the resource group, one of the resource group, let us see. So this is the resource group. So here I'm using this resource group. Let us say first subscription we need. We need one subscription. Within the subscription, let us place subscription and resource group. Let us place resource group. Resource group, and within that let us place our Kubernetes cluster. Let us see. So just go back to Kubernetes cluster service, create. I'm using Kubernetes cluster. So as of now, I'm using central US region, and within that let us select some resource group. Online store, e-commerce online store Archie, online store Archie. So there's the resource group. Let us document each and everything. And subscription, pay as you go. Or subscription is pay as you go. And resource group, e-commerce store RG. And next, let us mention e-commerce cube, online store cube. (005) is the cluster name. Kubernetes cluster name, online store cube RG. And as of now, I'm using dev and test because we don't have much resources. So that's why I'm using dev and test. And also I'm using like a default version. And as of now, I would like to disable these options, because let me disable this option as of now. Currently we have limited options, and also I'm using node pool. So just try to reduce this capacity. So let me use it. So just go back to manual. As of now, I'm using manual because of the limited resource limitations only. I'm using lower configuration. Just change the size. So I'm trying to use two CPU, 4 GB, but real time we should not use this configuration because of limitations I'm using. And update. And you see, currently I'm using two nodes, two worker nodes I'm using. And then let us see. And currently I'm using CNI, Azure CNI with my own network. So I'm using my own network, and also container insights later will enable. So I'll try to disable this. And so just see here, it is creating one more resource group for infrastructure resources. For that, it is creating one more resource group as well. Just mention name, online queue. It may take some time. Meanwhile, let us explore our manifesto files also. So you can see, so initial service, let us start with these services. So we'll see one by one services. Just go back to this picture. Front end as well as back end, these are all services. Let's see. So store admin, storefront. So these are all manifesto files. And one more thing you need to remember, currently we are using community code, and also we are using like Google GitHub registries as well as Microsoft registry. These are all images, community images we are using. Okay. So you can see this is the deployment, and most of the services we are using deployment except MongoDB as well as our RabbitMQ, order queue, as well as OrderDB, we are using stateful sets. Remaining services are related to deployments only. All other services related to deployments only. So these are storefront, front end, as well as store admin. You can see storefront as well as store admin. And also after that, you can see product place order service, place order service. So we are using like deployment, place order service deployment, and within that cluster IP. So just see, these are all internal communications only. Whenever you're trying to integrate with these services, so we are using cluster IPs here. So we are using cluster IP services. And here also we are using cluster IP only. Okay, these are all cluster IP services only. So whenever you're trying to integrate, but whenever you're trying to integrate with external world, so here we are going to use load balancers. So we are using load balancer here. We'll see that as well. So here also we are using load balancer. Okay. And then also we are using config maps. Okay. So let me show you that as well. Our RabbitMQ configuration map we are using. Okay. And also our Mongo as well as stateful sets. Right? These are all stateful sets we are using. Okay. So as of now, I'm using replicas one due to limitations, resource limitation. I'm using only one. And also to place orders, right? So I'm using virtual customer deployment. So someone should place orders. That's why currently I'm trying to place orders with two more microservices. One service is customers. Okay. So by using these services, it can place orders. And one more is virtual worker orders. This worker service will try to process these orders. Okay. They will try to process these orders. Okay. So we are placing virtual customer as well as virtual worker also. And also you can see product deployment. So these are all services you can see. Now here we are documenting all the steps. So now we are creating Kubernetes cluster. So once we create Kubernetes cluster, let us try to connect this Kubernetes cluster with our Visual Studio Code plugin. So here already added plugins. So Azure plugin, so also Kubernetes plugins. Okay. So here already entered my Azure credentials. I can log in my resources through this console. So let us go back to your Kubernetes cluster console. So just the console. Here we added few old clusters you can see. Now I would like to add my own repository now, my new repository. So nothing, sorry, my new Kubernetes cluster. So let us see. Still it is taking some time. Now we are ready with our Kubernetes cluster. Now we are ready with our Kubernetes cluster. So this is our cluster name, online store cube 005. So as of now, just see. So this is the cluster name and resource group name and subscription. This is the subscription you can see. Currently here we selected Central US. And also let us see other options also. Suppose if you are trying to observe existing resources, namespaces, and also workloads. Okay. So you can see all this configuration here. Also just see services. Different services you can see. These are all different default services. Okay. And currently we are using cloud managed Kubernetes. So master node will be taken care by cloud vendor. Okay. So these are all workloads. Pods, replica sets. So these are all related to kube-system, which are related to our system nodes. Okay. System nodes, you can see that. Okay. Also pods. So let us go back to one more scenario here. So just see, if you are trying to set up deployment, so first we are trying to set up pod. Within that pod, containers will be there. On top of that, so we'll try to set up replica set. So here you can see replica set. And on top of that, we can add our deployment layer. So now just see, this is a container. And this is the pod. And replica set. And deployment. Suppose if it is an internal service, we'll add cluster IP. So here we can add cluster IP. If it is internal service, if it is external, if you want to access it from external, you can add load balancer, right? So here you can add load balancer. So we'll see that services. If you observe our picture, you can see that. So previous picture you can see. So whenever we are trying to access it from outside, we are using load balancers. Internal, we are using cluster IP here. Now, so we are ready with our Kubernetes cluster. Now just try to log in this cluster with our Visual Studio Code. So let us log in this Kubernetes cluster with Visual Studio Code. Just go back to Visual Studio Code. So here you can mention command, AZ command. So here already installed Azure extension. Also we enable Azure CLI credentials also. We logged into Azure account also. So this is the command you can use. AZ AKS get credentials -n. And what is the cluster name here? So here the cluster name is, so here the cluster name, this is the one. Okay. Cluster name, also -g, what is the resource group name? So this is the one. Just enter this command so that we'll get credentials. Just go back to your folder. Let me switch to git bash. Now just see, currently we are in D drive online store, my online store. So here you can see these are all files are there. Right? These are all files, manifesto files are there. Okay. Now here I would like to execute this command, agent aks get credentials. Just go back to your Kubernetes extension. So just see, here it is there, right? Kubernetes extension. These are all previous clusters you can see. Now let us execute this command. So once you execute this command, now we can see our new cluster within this dashboard. Now we are trying to store our kube config within our local system. Also here I install kubectl as well. Right? We need to install our kubectl commands also. So just try to refresh it. Now you can see this is our cluster, current cluster, you can see that. Okay. So let me delete previous clusters. Okay. I'm trying to delete previous clusters, old clusters. And let me delete other cluster as well. Now, next one, let us see. So now let us execute one by one steps now. You see. So let us go back to our application. This is the entire structure. So let us start with front end. First, let us deploy storefront. After that, let us complete store admin. Let us complete layer by layer. Right. So first, let us deploy front end. Okay. So just go to your manifestos also. So here we already listed the section front end. Let us see. So here we already drafted our manifesto files also. Let us try to deploy our services. Front end, this is the one. Okay. So we are trying to deploy front end. Okay. So kubectl apply -f. So these are the deployment files we are trying to add. I'm trying to add these files. And also I'm trying to add two files same time. Now just see. So once you add the services, as of now, I'm trying to deploy with my default namespace. Just go to your workloads. I'm trying to deploy my services, what resources in this section. So you can see that as of now, these are all related to kube-system. Now I'm deploying my resources with default namespace. So by default, if you are trying to deploy any resource in the Kubernetes cluster, those will be deployed in your default namespace called default namespace. Default namespace. Okay. So if you want, you can change this namespace also. So let us deploy it. So here I'm trying to deploy my deployment as well as service. So service, nothing but whoever is trying to connect this service from external world customers, so they can start accessing the storefront. Okay. So here we deployed. If you are trying to observe these scenarios, just try to refresh here. So you can see this deployment also here. Okay, storefront. Still it is like still it is refreshing. It may take some time. You see, if you want to observe kubectl get all. Okay, so still it is taking some time. Okay, no, So meanwhile, let us deploy other services also. So meanwhile, let us see other service. Okay. So store admin as well. Let us deploy store admin. This time, let us deploy store admin as well. Just now we deployed our customer storefront, and now I'm trying to deploy employee store admin service. So store admin service as well as load balancer service also. So let us deploy it. So kubectl kubectl apply -f. So store admin. Let me take this YAML and also -f. So just enter. So now here we deployed second service also, second microservice as well as deployment as well as service also. These two things we deployed. So meanwhile, just go back to this section. So here you can refresh this dashboard. Still it's showing so 0 by 1. Now same way, let us complete other commands as well, other manifestos also. These are all services. kubectl apply -f place order -f place order cluster IP as well as deployment service. So you can see this place order service. After that, let us see product service also. kubectl apply -f. So let us see product cluster IP service. Similar way, deployment also, product deployment as well. These two things, let us see that -f, you need to use -f. So you can see. And also let us complete other steps also. Order processing, here we completed. Product also. Next, let us see order processing as well. Order processing, also OpenAI service. So let us see that. kubectl apply -f order processing deployment as well as -f order processing cluster IP service. And also let us see other scenarios like, so we need OpenAI service also. Okay. OpenAI service. So this service related to Python, let us deploy this. Later we'll try to onboard our OpenAI console as well. Okay. So let us see that. kubectl apply -f our deployment as well. And next, let us go back to our data and messaging. Till now, we completed backend services. Now, let us deploy our messaging as well as data also. So first, let us start with messaging. After that, let us see our DB as well. Let us see that. kubectl, let us see. Also, you can see this slide also. One by one services we are going to set up. So first, we started with front end, next store admin, and after that, we added our backend service. Now we are adding product service also completed, and also order and processing. Order and processing we completed. Now we are deploying our OpenAI service. So let us see our OpenAI service also. So let us see that. kubectl apply -f OpenAI service. Azure OpenAI service. So here also we need cluster IP service and deployment. You can see. Now just go back to your messaging now. Data, here we completed backend. Now let us see data and messaging. First, let us onboard order and QE. You can see this picture. Order and QE. Let us onboard that. Okay. So let us see kubectl apply -f. Okay. So let us onboard our order QE related services. -f -f RabbitMQ, our service, cluster IP service. So now let us deploy it. Okay. So here we created our service as well as our RabbitMQ's stateful set and our service also. These are all things here we deployed. Stateful set, config map, these are all things we deployed. Right. Now let us see. Let us go back to our next service called database also, order DB database. Okay. So whenever users are trying to purchase some products, transactions will be stored in this DB, MongoDB. So let us see that. Okay. kubectl apply -f. Right. So let us see order DB. Let us deploy order DB, stateful set -f, and you can see enter. Now we deployed for stateful set as well. Order DB stateful set MongoDB. Okay. So here we completed. These are all steps. Now let us go back to virtual customers, virtual customer as well as worker. Right? Artificial worker, artificial customer. Right? So the artificial customer or virtual customer, he will try to place orders, and artificial worker he will try to process orders. Right? So let us see that. So let us see that steps also. kubectl apply -f. So let us place the steps -f. Enter. So till now we deployed our manifestos. So here we deployed manifesto also. Manifesto or deploy services. Microservices we completed. Now let us execute our command to understand whatever components you onboarded. Let us see that. Whether just use kubectl get all. So you can see kubectl get all. So as of now, we deployed all resources in the default namespace. But real time, you can use your own namespace also. kubectl get all. Just see this picture. Okay. So if you observe here, deployment. Let's go back to this picture. Deployment. Within the deployment, replica sets are there. Replica sets. Just see this deployment. So here we created deployments like A service 1 deployment. So A service 1 deployment, and also to see order service 1 deployment. Okay. order service, place order service, and also just see product service, and also order processing, okay, and store admin, store front. These are all deployments, okay, and also virtual customer as well as virtual worker. Right? These are all things we discussed, we implemented, and also within the deployment, you can see replica set. Previously we discussed each deployment contains replica set and pods. Okay, you can see that structure also here. These are all replica sets and as well as stateful sets. So we use stateful sets for our Mongo as well as RabbitMQ. For these two, we use stateful sets. Okay. Now, next steps, let us see. Okay. So next steps. So till now we onboarded services. Let us go back to our Azure console. So you can see this console. Now let us go back to our console. So just try to refresh here. Now just observe only default namespace. Remaining things you can ignore. These are all deployments. Just now we observed our deployment. These are all deployments. Storefront, store admin. Okay, these are all deployments. Storefront, store admin. Okay, and also order service, product service, AI service. Right, these are all services you can see. And also similar way, just see replica sets. These are all replica sets. Just see only default namespace. These are all replica sets. And also we deployed stateful sets also. These are all stateful sets. And also within that, within the replica sets, you can see pods as well. Right? These are all pods you can see. Just observe only default namespace. Okay. These are all things we can see that. Okay. Now, so till now we observed. Next, I would like to access this application. Right? For that, just go to your services also. So here we discussed it, right? Storefront as well as store admin, they need load balancers. So here you can see that. Just see this. Services, under services, you can see, okay, storefront. So you can access your storefront as a customer. As a customer, you can access the storefront with this URL. Just click this option, storefront. Okay, this is a load balancer, public IP. Okay, so within that, you see different products are there. These are all different products you can see. These are all different products. You can see this option, products as well as carts. Right? This is all about our customer. Customer, he will try to access our online store with this URL. Okay? So with this URL, he will try to access it. So once it is done, once he places order, let us say he is trying to place orders. So let us say I'm trying to add to cart, you see, and 2 and 3. These are all things I'm adding. Now let us try to go to your add to cart, and you can see these are all things we added. Okay, now just use proceed to checkout. Still, if you want to shopping, do some shopping, just see this option. Now just see proceed to checkout. Okay, order submitted successfully. You see now here user visited this storefront. From there he placed order. Okay, now coming to like store admin, so he will try to validate product and he will try to order the process. Okay, order the process here. For that, we need store admin, we need separate console. So let us see that console also. Okay, let's see, there is an option called store admin. So this is the admin console. It means internal, this online store internal team console. So this console only visible to the store admins, right? Or you can say access to only store admins. But this console, whoever users trying to access this application, you can see that similar to your Amazon, right? Suppose if you are trying to access Amazon, this is console you can see. So by using this console, we can place our orders, but backend there is a team, admin team, they will try to process, right? So this is the our orders, admin console you can see. So here you can see orders, it is trying to fetch the orders, right? And also to see now here I would like to add new products. Just go to products again. So here, these are all lists is there, right? This is the list is there. So previously we discussed one slide. Let me show you that. So related to permissions, somewhere we discussed. Okay. Customer only view products and place orders, see own orders, but they can't do change prices, say others orders, delete orders. But admins, they can add, edit products, view all orders, cancel any orders. Right? Just go back to this console once, and just go back to admin console. Now here they would like to publish new products. Right? Just go to products. So these are all products are there. Now you can add new product. Okay. So just see here. So I would like to add new product name, let us see. Okay. So here you can add new product. So because here we already added AI service, that's why it is showing ask AI assistant, right? But as of now, we didn't integrate it. We'll see that. We'll try to add our OpenAI service also. Okay. So let us see my new product, new toys, baby toy, okay, baby car, let us see. Right. Price, let us say some 500, and keywords, car, description, baby car. Okay. Just save this product. So you can mention your images also. Okay. Save product. So once it is done, so just see here, this is the product. So this admin, he can edit this products also. So once it is done, after a few minutes, you can see that product also here. Product will be displayed here. But just see here, baby car. Just now we added this admin added some products, right? So whoever admin is there, he is trying to add some products here. Okay. Now product service, under product service, CRUD, create, read, update, delete. These are all operations we can do that. Okay. Now, so in this way you can see this services also. Okay. So till now we discussed about how to onboard our Kubernetes, like how to onboard our services like microservices. These are all things we discussed. These are all on microservices we deployed with our manifesto files. Okay. So for that, we implemented our Kubernetes clusters, and so within that we onboarded our services.